Welcome to Algeomulus Prep Academy. Today we're learning about Euler's method. So Euler's method is used to find an approximate particular solution of the differential equation y prime is equal to f of x comma y. The formula could be written as y sub n plus 1 is equal to y sub n plus h times f of x sub n comma y sub n. We can easily rewrite the formula based on the n value. For example, when n is equal to 0, we can rewrite the formula as y sub 1 is equal to y sub 0 plus h times f of x sub 0 comma y sub 0. Similarly, when n is equal to 1, we can rewrite the formula as y sub 2 is equal to y sub 1 plus h times f of x sub 1 comma y sub 1. Now let's try solving a problem. Use Euler's method to approximate y of 1.5. Use a step size of 0.5 given that y of 0 is equal to 9 and y prime is x plus y. This gives us y prime, which is equal to x plus y of 0, which is equal to 9, h, which is equal to 0.5, and what we're looking for, which is the approximation of y of 1.5. With this information, we can find n. We can find n by dividing 1.5 over 0.5. We get 1.5 from y of 1.5 and 0.5 from our h value. This makes our n value equal to 3, which is the amount of times that we repeat the substitution. Before we start, keep in mind that y of x is equal to 9, which means that we get the coordinate point 0, 9. This gives us x sub 0 is equal to 0. To find x sub 1, we add x sub 0 and our h value. This means that x sub 1 is equal to 0 plus 0.5, which is equal to 0.5. This also gives us y sub 0, which is equal to 9. To get y sub 1, you take y sub 0, add h, and multiply f of x sub 0 comma y sub 0. And then substitute the values that we know, which is y sub 0 as 9 and h as 0.5. In the parentheses, we substitute in our equation, which is x plus y, and substitute the values, which is 0 and 9. Y sub 1 is 13.5. To help us, let us recall our answers from the first part. X sub 1 is equal to 0.5. Y sub 1 is equal to 13.5. And remember that h is equal to 0.5, which doesn't change. Similar to part 1, we get x sub 2 by adding 0.5 and 0.5. This gives us x sub 2 is equal to 1. We get the first 0.5 from x sub 1 and the second from our h value, 0.5. Again, similar from part 1, we get y sub 2 by taking 13.5 plus 0.5 multiplied by 0.5 plus 13.5. This gives us a value of y sub 2 as 20.5. We get 13.5 from y sub 1. then 0.5 from h value, then 0.5 from our x sub 1, and the 13.5 from our y sub 1. This makes y sub 2 20.5. Again, let us review the values from the previous substitution. X sub 2 is equal to 1, y sub 2 is equal to 20.5, and h is still equal to 0.5. To get x sub 3, we add 1 and 0.5. This gives us x sub 3 is equal to 1.5. We get 1 from x sub 2 and 0.5 from h. For y sub 3, we take 20.5 plus 0.5 times the sum of 1 plus 20.5. Gives us y sub 3 equal to 31.25. 20.5 is from y sub 2, 0.5 is from h, 1 is from x sub 2, and 20.5 is from y sub 2. We know from the previous substitution that x sub 3 is equal to 1.5, y sub 3 is equal to 31.25, and h is still equal to 0.5. Going back to the question, it asks us to approximate the value of y of 1.5. Since we know that x sub 3 is equal to 1.5 from the previous substitutions, we can determine that the value of y of 1.5 is approximately 31.25. Make sure to use the approximation symbol and not the equal symbol since it is an approximation. Thank you for watching, and I hope that you have a better understanding of the Euler's method. Make sure to like and subscribe to this channel for more content. Thank you!